Alright, this is going to be episode number 17 in our video series, going from a complete noob to a veteran ASM coder. Previously, we talked about making codes execute on set intervals, so now we're on the second thread of our expert tier level, creating loops. There's all sorts of purposes and reasons why you would create loops and whatnot. But what are loops? Essentially, they're just a cycle of repeating PowerPC instructions that you can use for certain purposes. In earlier episodes, when you guys are learning how to first, be a basic code creator, I talked about that generally speaking, instructions execute from top to bottom. Obviously from now, after you guys have made some codes by now and you've gone beyond intermediate level, you know that there's so many exceptions to that rule. You can branch backwards. There's all sorts of conditional branchings, but there's loops too, right? And obviously, when you make loops, you don't want them infinite, or the game will just loop forever and crash. So what's our goal? Let's say we have some words in memory. We'll put these words in memory. And we need these words to say, we need them to get to here. We want them to get to here, right? We essentially want to take something that's already in memory and move it to a different spot in memory, if you will. So of course you could do something like lis, this, load word, store word, load word, store word, over and over and over again, but that's repetitive and it's unoptimized. So there's two types of loops that we want. The first one is my favorite, the subtract immediate carrying loop, and then we have the branch decrement if not zero loop. So we have the sub IC loop as the first loop and the BDNZ loop. Alright, so we'll cover both. So let's just go over the one I personally like to use. The downside to now these both take equal amount of instructions to do. The downside to the sub IC loop is that it takes an extra use of a general purpose register. So if you're a little tight on extra registers, then you might want to use the second type, which we'll cover later. But for now, let's cover the first method of loop, the sub IC loop. Okay, so we'll need to establish a starting point and an end point, right? To where our memory, our words in memory is at and where we want them to be. And we also need to tell the CPU how many times to execute this loop depending on how many words we're transferring or how many bytes or half words, but for ease of use we're using words. As you can see, we have 1, 2, 3, 4, 5, 6 words. So we'll want this loop to execute 6 times. So now we're not going to worry about any safety protocol. We'll just use R14 and up, but obviously this would not be correct if we're following some safety protocol. This is just for demonstration use. So I know in the thread I did something a little bit different, but just for variety, this video will be slightly different than the info that was put in the thread. So this is for 6 words we got to transfer. Okay, pretty simple. So now we need a starting point. So let's look at our starting point. 8,000, 1,500. So when you do these starting points, you want to put the entire memory address, upper and lower bits, into the same register. You'll see why here in a little bit. Okay, so we're good, right? We can continue on to the next part of making our loop. Well, actually, we're not. Essentially, what we're using these new instructions we're going to cover. We're using store word update, load word update and store word update. And essentially, they're like store word and load word, but they increment the source register value every time they're used, if that makes sense. So, and you use the offset amount in these instructions to increase the source register amount every time that instruction gets executed. So this is why they're called store word update. They always update with a new source register value. Or load word update. They always update every time that instruction gets executed. So now this might be a little confusing, but first notice how a word is 4 bytes in length, or like an offset of 4. So an offset of 4 is this, offset of 4 continuing on is this, then that, then this. So we need to make this value and subtract by 4 because each word is 4 bytes in length, and you'll see why in a second. So instead of doing this, take 4 off like this. Okay, so that's our actual starting point for our loop. So now we need our end point applied. Now we wanted to store. Now remember, we started here. This is where our stuff is at, but we want it to go here, right? That's where we want to end up, our final destination. Well, let's use R16 for that, or whatever. FC. So obviously, because these are using the same lower bits, you could do a different way to OR these for any advanced coders watching this. But for simplicity use, we'll just change this, the 0 to 1 for our start destination to our final destination. Apply the same logic. Take 4 away from the 1500 because each offset, each word takes up 4 bytes. So now we got our amount of times our loop is going to execute, which we will refer to this register as our countdown register. It counts down, obviously, from 6, and it'll decrement every time our loop will execute, and I'll show you how we do that. Our starting point and our end point, or our first address of our endpoint for our updating instructions, and you'll see what I mean here in a bit. Okay, so now we use load word 0 update. Okay, and I'll demonstrate this in Dolphin so you guys can actually see what's going on. So what's going to happen is it's going to load the word from the offset of 4 to 15, right? So we load this first word right here. So at this point in time, when this first executes, R17 right here will have this value. And once this instruction gets executed, it actually increases the value in here, which is originally this, by 4. And it does this every time this instruction gets executed. So when this instruction gets executed the first time, R15, instead of being 14FC, goes to 1500, then 1504, then 1508. So we got loaded in R17, our first word. Now we got to store and update it. Like this. Same concept with the store word update. R16 starts off with this. Store it to the offset of 4, which is 8100, 1500, which is our first word spot. We want where our first word is going to be in our final destination. But since this is an updating instruction, it adds 4 to R16 every time this gets executed. Okay, so now what is this instruction? We don't really need to know it in detail. Just understand, don't worry about this carrying symbol of this instruction. Just understand that we're subtracting 1 from 6, and we re-put it back into 14, so it keeps updated, if you will. And we have a record, so we get a free use of compare R14 to 0. So we get a free use of this, right? Because we have the record function on the subtract immediate instruction. Now we need, so what's going to happen is we're going to make this repeat until R14 is 0, because we're subtracting 1 every time from it. So we're going to call this the loop. Now obviously, when we're this conditional branching, whenever it's not 0, we want the loop to repeat. Where does this label name, where do we want it to go to? Well, at the beginning of our loop, like this. So what happens is we set our countdown register, set our start and end points appropriately with the offsets, keeping in mind the offset values for our updating instructions: load, update, store, update, decrement the countdown register, and obviously if it's not 0, go back to here, repeat. Go back to here, repeat, 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 repeat. Once it's 0, it will execute whatever is here once the loop is done. Make sense? Okay. We can go ahead and put this in. Where are we at in our code view? Yeah, we can do that. Okay, so I already have this in memory. Okay. Let's go ahead and put raw ASM and compile this. Alright, so we have to go ahead in the code view. This is going to take a minute, but let's go ahead. Replace all these instructions so you can actually see this happen live. Just so you can get a visual idea, because you know that's the whole point of these videos, is to get a visual idea. Probably should have done this beforehand, but it's okay. If you need to, feel free to rewind the video if I went too fast. Alright, here we go. So now, check it out. We're going to put this here. Where's our registers at? Keep an eye on the registers. We'll put that here. Alright, where is my little dolphin window so I can step through this? Okay, so we're just going to let this instruction execute. Now here we go. As you can see, R14 turns red. We set our countdown register. Set our starting point accordingly, which is amount of 4 away from our first word. Set our endpoint correctly, which is that, 4 away from the beginning of our endpoint. And right there, see what happened? We loaded the first word in the R17. R15 gets incremented by 4 automatically in the source register of the load word 0 update instruction. Now check this out. Let's just go here. Now I'm going to go here in memory. Watch what happens. Let's execute the store word update. Boom. See what happens? Now R16 gets updated accordingly. And look, we got a word in memory. Let's go back. We actually leave this right here. But just see, we got the 1s, 2, the 4, the 5, the 6. Just so you know they're there. We'll go back up to our endpoint. Now look at R14, okay? Keep an eye on it. I'll move this down a bit. Okay. You can also keep an eye on the condition register. Decrement. We're not at 0 yet. So branch if not equal, we're not at 0. Go back to the load word. Load it in. We got the second word in R17. Store and update. Decrement. Repeat the loop again. Keep going. Alright, we got the final word right here. Store it. Look what happens to R14 in the condition register. Boom. R14 is 0. We no longer execute the loop. And there, we got our data from here to there. Alright, and that is it for method number 1. Let's go to method number 2. This will be using the branch decrement if not 0 loop. So if you're a little tight on registers, this will use 1 less GPR, so it's pretty good. So this is a little different. We'll just modify the source we have now. Okay. So you're going to set your countdown register, but you're going to go ahead and use now in one of the earlier episodes I mentioned the CTR register right here. The game naturally likes to use this as either for loops or for branching to a certain address, but mostly loops. So the game will use this a lot. It's called the CTR. Okay, I think it stands for count track register, maybe. Might be butchering that, but you can use that as well. So this is the modified source. Move that to there. Okay, set your begin point, your end point. Now check this out. Now I know in here I didn't use it in the thread, but we can reuse R14, right? Now you go change this to this. So what's going to happen is, well, one, we don't have to use a fourth general purpose register. So that's the one plus side of using this. The downside is if for some reason you are unable to use the CTR, because maybe you're looking beyond your code address or looking before it, or somewhere you're actually within a big loop in the game and you can see that you're within this gigantic loop that's using the CTR, obviously you can't use the CTR. So this is kind of like the same thing as before, but it will decrement the value in this register, and once the value in this register is 0, it will continue down here. So instead of using a GPR that you can watch get decremented over time, you're just looking at the CTR instead. Makes sense? Okay, and that's really about it. Those are the two methods that you can use to create loops. Whether it be you just want to transfer data or whether it's for something else. Alright guys, that is it for that episode. In the next one, we'll be talking about calling static functions in the game. Alright, thanks for watching.